for next talk, we have the Argyle guys talking about some really interesting stuff that they've done with Accumulo in general, and also particularly some stuff with Facebook's Presto SQL engine, which I think a lot of people here are excited to hear about. One thing I kind of wanted to say about these guys, so I heard a rumor that there was this Silicon Valley startup company that was using Accumulo, and they had no government ties whatsoever. I was like dumbfounded, and I finally met them, and they actually like feel like they made good decisions, and so I was happy. I think I don't know. I hope I'm not embarrassing them. They are one of the first people I've actually heard of that selected Accumulo not because of visibility labels is one, and that were really outside of the typical circle of people. So I think they're a great example of what Accumulo can do. So with that, I'll hand it over. Thanks.
Thank you, Don. In fact, I first heard about Accumulo from Don, and I'll tell you the history of how we got there. But my name is Arshak Navruzyan. I'm VP of Product Management for Argyle. So I'm going to just tell you a little bit about our company and the use cases that we target. Mainly our focus currently is financial services and telecom. That's kind of the history of our company. But more and more we're working with defense contractors, et cetera. I'll just go through the first part of this, tell you about the company and use cases, show you a quick demo of the product, even though the VPN may or may not be up, but let's hope. And then I'm going to hand it over to one of our senior architects, Ara, and he'll tell you how we actually built the Presto Accumulo connector. If you have specific questions, he can answer those. So we've been around since 2009. As Don mentioned, we are venture funded. We're based in San Mateo, which is about 10 miles south of San Francisco. And the history of the company is essentially we had an in-memory database technology built for real-time analytics. And we did a lot with that. We took it into e-commerce, places like eBay, PayPal. We had a number of telco customers using our technology. But we realized that, I don't know, I guess we should have thought of this from the get-go. Big data doesn't really fit into memory. Particularly when it's coming at you at 10 gigabits per second. So I'll tell you a little bit about how we ingest data. We actually have a DPI capability, deep packet inspection capability, that takes data live from the network and serializes it into Accumulo. So the big trend that we're seeing, and we decided instead of continuing on with our proprietary technology to embrace Accumulo and embrace Hadoop, is this is a big wave. It's really changing the way the enterprise thinks about their systems. Right? It used to be the application was king and application functionality was very, very important, and data was a byproduct. And that's changed now. Data is your main asset. Application functionality just sort of falls out. Those various use cases just fall out of your data. And machine learning obviously plays a critical component in that. And we looked very hard at what have Facebook and Twitter and Google and obviously the NSA done to essentially make this kind of new data-driven application possible. What stack what have they chosen? And we figured out that it's a distributed file system and a distributed key value store on top of that file system. And we looked at all the usual suspects, Hypertable and Cassandra and HBase, et cetera. And then I remembered Don talking about Accumulo, and I said, I wonder how those guys are doing. I should look up that project. And I actually went and downloaded it myself. I'm a product manager. I'm not that technical. I went on Google Compute Engine, stood up my first node, and started playing with it. I thought, wow, the shell is really cool, and the fact that I can ingest at these rates is very cool. I wonder if I could add a second node to this. And of course, as a product manager, I got stuck. The Google Compute Engine has some weird firewall stuff that I just couldn't figure out. There's like an external firewall, and then they run a Linux-level firewall, and the Linux-level firewall was just beyond my abilities. This was on January 1st, 2014. And Josh Seltzer, who absolutely has no life, logged in. Thank you, Josh. Logged in and helped me figure this out. So I got my second node up and running, and now my speed doubled. And I was just blown away. And start advocating for this technology internally. And here we are later, 5, 6 months later, it's become a critical component to our stack. So let me tell you a little bit about the use cases, how we're using this technology, you know, kind of the functionality that we're trying to achieve with this technology. These are some of our customers. Vodafone is a very interesting telco. They're the second largest telecom carrier in the world after China Mobile, something like 400 million subscribers. And in some of their regions, in Europe in particular, they have a fraud problem where someone will get a premium number. And in Europe, these premium numbers are not obvious. You know, it's not like a 1-900 number the way it is in US. It looks like a regular number. And if I'm a fraudster, I will get this premium number and I will start making calls to lots of people on the Vodafone network. And people see these calls come in, like a one ring, and you know, they don't necessarily answer it. They don't recognize the number. But then they wonder, I wonder if that's my friend and he got a new phone or something like that. So let me call that number back. You call the number back, you get charged $5.99 a minute or some. And this, you know, either the subscriber bothers to call Vodafone and ask for their money back, in which case Vodafone eats that charge, or they don't, right? Or it never goes, it goes completely unnoticed. Well, this is a problem to the tune of like $2 billion across the entire telecom world. And there are a number of these sorts of use cases. And what we're able to do is we have, as I said, we have this deep packet inspection technology that's essentially able to monitor all these live calls, SMS messages, et cetera, on the carrier network. So the normal way to do this would have been wait for the Ericsson switch to essentially produce a CDR, run that call detail record, run that call detail record file through an ETL process, ingest it into a Teradata or an Oracle, and a day later, you'll see a subset of this data. The Ericsson switch decides what information it's going to log, right? We were able to tap the network, listen to the packets. In their case, it's ISOP packets on a SIGTRAN network, if any of you are technical, which I'm sure all of you are. And serialize this data into Accumulo, and then be able to give this to an analyst to be able to just run SQL over it. You know, show me people that have made more than 100 calls within the last 2 minutes where the calls have not been returned, or you know, something like that, or you know, after multiple rings, the person didn't answer. Those types of things, or being able to say, you know, group it by country. You know, very often they know the places where these calls come from, right? It might be Cuba or Caribbean or whatever. There's certain hotspots around the world that the carriers want to monitor. They know this is where these premium number activities are happening. So we managed to apply Accumulo to a business problem that's, you know, very tangible, very quantifiable. Like over a weekend, they told us that using this technique, they were able to save about 650,000 euros out of a very small region, a region that only had about 200 million subscribers. So one attack could have cost them basically $1 million for a very small part of their business. We've done similar, we're working on similar use cases for other telcos. SK Telecom is a carrier that's very interested in spam and phishing. In Asia, we're told about 30% of SMS can be spam or phishing. So how do you filter that content out to make sure that your subscribers are having a good experience on your network? eBay uses us for a slightly different use case, issues around scraping the website and doing arbitrage of their listings. We're able to essentially pick up that data and slow those users down, essentially. Not completely turn them off, but make it a little bit harder for them to use the API if their activity looks suspicious. So, in a nutshell, we've gone from, you know, the before and after picture for us is we've gone for 24-hour batch ETL processes where the focus is really on in-memory analytics. You know, the other thing we noticed within our target customer base is it's kind of a patchwork quilt approach in terms of the technology. They have a batch system that's primarily MapReduce. They may have a real-time technology like Storm or Spark streaming, et cetera. There's usually a NoSQL component involved. There's an in-memory SQL database, et cetera, lots of ETLing, et cetera. And that complexity is just overwhelming. I think even for a Silicon Valley tech company, you know, Nathan Marr's Lambda architecture can get very complex when you go outside of that world into typical telco world or financial services world, it's unmanageable. They don't have 30 engineers from Stanford and Berkeley to work on this stuff, right? So I think you need simplicity. And I think we've gone from, application log files. The other thing we noticed is, our customers told us this, like log files are great, and what, we saw with analytics on top of log files is fantastic, but what if I have a piece of malware? Like, that's not going to write, log files. But I can see that malware trying to communicate over the network. I can capture the activity of that malware as an example. So new world is, it's real time. It has to be petabyte scale, right? In-memory doesn't work. We think Hadoop is a stack. It's as big of a stack shift as LAMP or the RDBMS stack shift that happened over the last 10, 20 years. And we think application log files are a good start, but network packets can kind of take us further. With that, I'm going to just jump in and show you guys just a really, really quick demo. Let me make sure my VPN is still alive. All right, great. So here's a simple UI where I can come in here and type in the name of a protocol I'm interested in. Let's say it's DNS. And this could be, as a typical enterprise, maybe I want to see what are my end users querying. So I can take that DNS protocol. I see there are essentially two aspects to DNS. There are DNS queries and DNS responses. I can essentially decide which of these attributes I'm interested in. If I need to know what a particular attribute is, it'll explain it to me. And I can essentially turn on this protocol. This means our deep packet inspection is now going to listen to this protocol, take these packets, pull out those attributes, sessionize it so that if it's a phone call, for example, it'll group all those under one row key and send it to Accumulo that way. And once it is in Accumulo, essentially we have a schema, right, that allows us to query this data. So I'll switch over. So here's our Presto Accumulo integration that Don mentioned. So if I have a table, let's say, let's go look at it in the good old Accumulo console. So I have a table in here called demo. It's got about 5 billion entries in it right now. And I'm actually, I think, still even ingesting data still. So I'm writing in 500,000 entries per second as we do this. And that table obviously has a row key that is split. So it's made up of a number of tablets, right? 257 tablets, okay? So we're running this on a small cluster of, I think, about 15, 16 nodes, something like that. So you can see each tablet server, how many tablets we're hosting. So in Presto, there's a little bit of metadata that essentially maps a relational view on top of that Accumulo table. And you can see it's pretty much the same kind of representation as what you have in Accumulo. It's column family, column qualifier. We had to use the @ sign, colon wasn't supported by Presto for whatever reason. So we essentially, as a user, you pick out a subset of the attributes that you're interested in, and you define what data type you want those to show up as in SQL. Once you do that, and you can do that just here, command line, just say create table, etc. Or in our GUI, when I turned on that protocol, we essentially sent that metadata to Presto. And all our metadata is just kept in Zookeeper. So this UI essentially said, the user is interested in these attributes from these sets of protocols, sent that metadata, and set up all the ingest plumbing. So once all that happens, I'm able to run SQL queries over this data that I essentially gathered, I harnessed from the network. So here's a really simple query scenario where I'm saying, select the application, count up the number of packets from the table called demo, group it by application, and in this case application really means protocol, and then show me only applications that have more than 500. So I'm doing an aggregation, right? I'm doing a count, and then I'm doing a having clause. And then order it by the second attribute, which is the count one, and then show it to me in descending order. So I'll execute this. So the way Presto works is it's coordinator worker architecture. So it launched a bunch of jobs out to each node, that's co-located on the tablet server. Ara will go into a lot more detail about this. But we can see the queries running. So we had 5 billion entries in that table when it's key value representation. That same table in relational representation, we've mapped 10 attributes you can see there. So it roughly adds up to about 450 million entries in that table. And we're scanning at a rate, you can see it's about 10 million rows per second. So it's been about 44 seconds that we've been running this query. This query didn't have a where clause, so we're basically doing a full table scan. We're essentially coming up with an aggregation. And this is pretty. We think this is pretty decent performance, right? Considering we're hitting, all the tablet servers, and there you can see it finished. So we scanned a 4 billion entry table or 450 million row table in under a minute. So on a small commodity, footprint hardware. So that's kind of my spiel, and I'll hand it to Ara to explain exactly how he did all this magic.
All right. How many people have heard of Presto? Okay, not bad. So Presto was open sourced by Facebook. Initially, they created this project to take care of this scenario, to query data stored in Hive, basically. But instead of querying through Hive, they wanted a faster approach. They wanted to have better performance, because Hive sits on top of MapReduce, and it's very slow. So they created this Presto engine. There's a CLI for where you can run the queries. There's also the REST API that you can call to run the queries and get the results back. The main component is the Presto Coordinator, which is responsible for translating the SQL query into multiple distributed jobs that are run one after the other on the Presto workers. So, and each worker would then go over a smaller portion of the data assigned to it, do the computation, send the result back, and then aggregate it, shuffle it, whatever is needed. Pretty similar to MapReduce, but compared to MapReduce, the main difference is that MapReduce stores every step of the MapReduce jobs on the disk, and does a lot of then back and forth over the network and so on. But this one is gets rid of that, and it's pretty faster. So if we define a range of for the performance of queries, we have sub-second queries if the data is pre-computed, and then we have full MapReduce jobs which are pretty slow, but we target something in the between them. It is queries in the range of seconds to tens of seconds, things like that. But the good thing is that these are ad hoc queries. I mean, you can go over all the data that you have and try to find whatever you're looking for. So as Arshak was showing, there's a schema involved. The schema is stored in the case of Hive, for example. In the Hive meta store, the data is actually on HDFS, whatever format that Hive can understand. And we took this and turned it into this. So Presto CLI is still there. Presto Coordinator is still there. Instead of using the Hive meta store, we use Zookeeper, and we store the table schemas in Zookeeper. It's pretty simple. We just dump the JSON of the table schema there and read it back, cache it for some time, things like that. And then, all the worker machines have access to that schema, and we leverage the Presto Coordinator to assign the correct range of scanning or whatever it needs to do to the correct worker instance. And then each worker instance goes over the assigned range and talks to Accumulo, fetches them, returns it to Presto, and Presto, like a really good container, works with the data that we returned from Accumulo and provides all the functionality that it provides. It has very fancy functions like time window functions and fancy date operations and a lot of these things. And by just connecting it to Accumulo, all that functionality, all that functions are provided, and you can use those features. And so this is the first step. This was the first thing that we did. But we could go one step further to optimize it even more. This was what we did after that. So I tried kind of to show that workers and Accumulo nodes are actually co-located. And so instead of fetching the data over the network from Accumulo, we actually co-located the Presto workers and Accumulo tablet servers, and we try to assign a worker instance close to the tablet server, which it is assigned to. So in most cases, it is local. In some cases, it can be, over the network, but mostly it's local. So because of that co-location, it's just, local fetching from Accumulo. We can use the cache or whatever to speed up the process. So that's it. Yeah. By doing this, we were able to, have the millions of records per second performance, basically. Now, one other part of the puzzle was taking care of this schema-less, schema-full paradigm, because in Accumulo, everything is schema-less. There's no schema at all. I mean, you can dump anything you want in there. But Presto expects a predefined schema for tables. You have to say that I have this table. It has these columns, and this column is of this type. Then you can actually query them. Without that knowledge, for example, the time window function or date functions, things like that, they cannot work, right? And so we had to find a way to map these two words to each other. And we stored the schema in Zookeeper. We defined kind of a mapping between the two. We say that in Accumulo, this column qualifier column family maps to this column in Presto in this table, and it has this type. It has these extra information that we need to make this happen, and we store it in Zookeeper because it's just fast, and if something changes, we get notifications back and so on. So pretty easy mapping, actually. As you know, in Accumulo, all the data is in byte arrays, basically. It's just every cell is a bunch of bytes. But Presto needs to be aware of the data type. So that piece of information is also something that we store in Zookeeper in our schema mapping. And there's another interesting thing about the two worlds is that we can say that somehow, not exactly, but somehow Accumulo is kind of a columnar storage format, kind of, from the point of view of the person who deals with the data, because it is not really row-oriented. It deals with cells. You can set the value for a cell, which is defined by a row and a column qualifier and timestamp and so on. So you can fetch specific cells out of many rows and expose those cells to Presto, which is exactly what Presto expects, because Presto was designed to be used for analytical functions, right? In analytical scenarios, you are not going over all the columns in each row. That would be too slow. You are, for example, if you're trying to do a where something equals something, then you just need that single column out of each row. And so we can optimize that. We can ask for specific column qualifiers, column families, and so on. So the mapping was kind of okay. It was not like we were mapping something very row-oriented to something completely not row-oriented. But so we had to introduce the concept of secondary indexes also on top of this, so that we can optimize queries. Because if you want to do some query like, I don't know, select something from this table where this column equals that or greater than that, if that column is stored in a secondary index, then you can go to that secondary index, try to fetch that specific column instead of going over all the data that you have. So this is something that we're actually actively working on right now. So we defined a secondary index mechanism, and we also considered using locality groups. We thought that maybe we can use locality groups to, if you're querying column X frequently, maybe it makes more sense to move it out to a locality group so that all values for that column X appear one after each other, and this columnar, scanning could be optimized. But after spending some time on it, we realized that that's not something that we can use for this specific issue. So we introduced a secondary index table. For every table in Accumulo, we have another table with the underscore index postfix. And what we're trying to do is that using Presto's predicate pushdowns and so on, we are trying to optimize the access patterns. We are trying to, instead of to go over everything in the main table, we redirect that and check the index table first. That's what we're trying to do. And that is possible because of the predicate pushdown mechanism in Presto. And that's something still in progress, but we think that it's going to help us achieve even higher performance numbers and so on. To make that happen, for example, in this case, let's say table 1 is one of the tables that we have, and it has information like that. We create the underscore index table so that we can, optimize queries like select everything from table 1 where first name equals Joe, for example. And instead of going over all the values in the table 1, we find out that there's a secondary index on top of that column, use the predicate pushdown, and redirect that query into the index table. Then we can use Accumulo's, range scans, batch range scanner, and so on to just directly go to that to the index table and find the correct values. There's so many details in there, like the shard byte and so on, that we use so that we don't suffer from the burning Kindle phenomena. If you don't kind of randomize all the values so that they appear on many nodes instead of just one node, like if you have the time series data. If you write all the numbers with an ID, which ends up on one tablet server because it's writing the last data, chronologically, then you're in trouble. We use the shard byte and so on to distribute that over all the nodes that we have. And OK, so I just finished.
Time for questions.
Yeah. Yes.
I think we put the shard salt or whatever it's in the front of the.
The shard value is actually computed from the field values themselves. It's not something random, So for example, in that case, first name, the shard byte in front of that row is actually computed from first name and last name, things like that, Yeah. So it's pretty predictable.
In our indexing API, essentially, our ingest API, you specify how many fields you have in your hash and pass in those fields, and it'll hash it out to a value for you.
Yeah, we have an API which is responsible for writing to the main table and also creating the index table.
The Accumulo Presto connector, is that now part of Presto itself, or is that something?
In our code base, yes. It is not open source. We haven't yet contributed it back to Presto.
Yeah, we're still
discussing.
trying to decide what our product packaging should be. Yeah. Yeah, you can look at the PrestoDB documentation. They support windowing functions, and we've tested those, and they work natively. Sure. Two things were important to us. We're a small company, about 25 people, so administration overhead was very important. I had to be able to do this as a product manager, and I knew the people I would hand it to would be kind of our QAs, actually. And I knew that we weren't prepared for the complexity of region servers and all that other stuff. And then just in our own little lab environment, we have about a 20-node cluster. The performance difference we saw was on ingest. Accumulo was twice as fast as HBase. But again, we're not experts at either one, so we could have blown some setting, and that was the reason. But that's what we experienced.
Yeah, we just have one index table for each table, each main table that we have. We just dump everything in there. The shard byte is kind of important so that we do the ordering correctly. So that, when in Accumulo we're doing that range scan, we end up scanning the correct range.
So yeah, one index table for all the attributes that you want indexed. And the query parser will hit that index table first, get a list of the row IDs that match it. And if that's all you're returning, you're done. If you want to return some attributes for those rows, it'll fetch those attributes out of the main table.
Because Presto does that. Actually, it's pretty interesting because Presto has this pluggable connector architecture. So as a connector, you're actually only responsible for providing the data to Presto. You can go one step further and deal with the predicate pushdowns and so on to optimize that. But to get the basic functionality, the basic integration going, it's not. I mean, it's just providing the values, to Presto. And when you provide the values to Presto, everything that Presto provides, all the functions and so on, they are possible.
So wildcard searches, yes, by virtue of Presto doing it, not for the secondary index. The secondary index is an exact match. Yeah, we're actively considering it. We're venture funded, so we just need to figure out how to best monetize from there. So, all right, thank you very much.